Okay, let's try out another example that's a little bit heftier. So here we want to take an inverse Laplace transform. There's a lot of stuff going on here, but we can sort it out. So what do we see? We see this exponential function as a factor of these of this expression. And so this is going to be the inverse Laplace transform of e to the negative 2s times all of this stuff, s squared plus 3 over s times s plus 1 squared. All right, so that means we can use our formula that the inverse Laplace transform of e to the negative as times capital F of s is going to be equal to ua of t times f of t minus a. So our first step here, so besides noting that a is going to be equal to 2, is going to be to find the inverse Laplace transform of this expression s squared plus 3 over s times s plus 1 squared. This is going to be our little f of t. Okay. Because we don't recognize this formula from our chart, what we're going to need to do is break it down into smaller pieces using the partial fraction decomposition. So let's start with that. Okay, so our denominator is already nicely factored for us. So we're going to have s squared plus 3 over s times s plus 1 squared. We're going to have 3 terms, a over s plus b over s plus 1 plus c over s plus 1 squared. S appeared just as a single factor, and so it just gets one term. S plus 1 shows up as a square, so each power gets its own unknown. We can use the cover-up method to find a. So a is going to be equal to s squared plus 3 over s plus 1 squared, where we're evaluating this at s equals 0. That gives us 3 over 1 squared, or 3. Okay. All right, next up, let's look at the other terms. Let's look for these guys. So we're going to add everything together in order to find them. So I'm going to be multiplying across by s times s plus 1 squared to get rid of the denominator. That gives us s squared plus 3 is going to be equal to 3 times s plus 1 squared. The b term has a single s plus 1 in the denominator to cancel out, so that gives us s times s plus 1. And the c term has an s plus 1 squared in the denominator that cancels, so we'll just have c times s. Okay. All right. So we can do a little bit with this. For example, we could evaluate where s equals -1. And that tells us that 1 plus 3 is going to be equal to 3 times 0 squared plus b times 0 plus c times -1. Or 4 equals -c, so c is -4. All right, so I'm going to put that in here. All right, so 2 down, 1 to go. So this is equal to -4. Good. All right, to find our final term, we can either plug in any other s value, or we can do something like compare coefficients. So if we take a look at our s squared terms, our highest order terms, for example, this is maybe helpful. On our left side, we see 1 s squared on the right-hand side, we're going to see 3s squared plus bs squared. So 1 is equal to 3 plus b. So b here is equal to -2. All right, so what we've done is we've taken this expression that we wanted to find the inverse Laplace transform of, we've broken it up into a bunch of little pieces, and now we're going to take the inverse Laplace transform of each of these pieces. Okay, so inverse Laplace transform of 3 over s. We're going to just look at the inverse Laplace transform of 1 over s and multiply it by 3. Then we have -2 times the inverse Laplace transform of 1 over s minus -1, matching it to the exponential form. And then this last one might be a little bit less familiar, this guy. So let's hold on to it, and we're going to take a look at our list of Laplace transforms and see what this might match up with. So I'd like you to look that over. So we had -4 over s plus 1 squared. So take a look and see, do you see anything that has a squared? We have a shifted s in it. Yeah, totally. So if we look at number 11, this is going to be helpful. So we have -4 over s plus 1 squared. So the first part we're going to match up is our denominator. So we have s minus -1. So our a here is -1. And this is squared. So n plus 1 is equal to 2. So n equals 1. And so on top, that what we want to see is a 1 factorial or just a 1. So I'm going to just be thinking of multiplying this whole expression by -4. Okay. All right. So this is going to be, our formula says that our inverse Laplace transform is going to be t to the first e to the -t. Okay. E to the first e to the -t. Okay. So we had -4 held to the -1 of 1 over s minus -1 squared. Okay. So this is 3 minus 2e to the -t minus 4t e to the -t. Okay. And this is our little f of t. Okay. Because our formula says we're going to take this little f of t, and then we're going to shift it to the right by a, and our a here is equal to 2. We have just a little bit of work to write down our final answer. So this is going to be equal to u2 of t. And then I'm going to write f of t, but every time I see a t, instead of writing t, I'm going to write parentheses t minus 2. Okay, we want to shift our inputs right by 2. So we have 3 minus 2e to the negative t minus 2 minus 4, and here's another t, so that's going to be t minus 2 e to the negative another t, t minus 2. Okay, all right, and so this is our resulting inverse Laplace transform. Great.